All right. Okay, welcome everybody. I'm Philippe from the Autodesk Developer Network, the fourth partner development. So today I'm going to present you the slides and demos that we show at our annual DevDays conference. And I'm going to talk about the Forge Web Services API. So let's get started. So here is the agenda for this presentation. I will talk about the OAuth authentication, the data management API, model derivative API, and the viewer. So the way you can see the Forge APIs is like a set of building blocks. Autodesk provides those building blocks, and you use them to build the spaceship or the web application. So every API, every web services based on Forge is using the OAuth to authenticate the request. So let's talk a bit about OAuth. So you have two types of OAuth authentication. One is called the two-leg. So in this authentication, the user will connect to your app. So most of the time that would be a website or a web page, but it could be a mobile app or a desktop app. And in the background, your application will connect to the Autodesk OAuth server, and it will use a set of keys, secret key and client and consumer key, in order to request a valid token. So in that authentication system, the authentication is transparent to the user. So it means that your application can be branded, and the user doesn't need to have an Autodesk account, and it's completely transparent for the user that your application is using the Forge Web Services. In the three-leg authentication, the situation is different. In that case, the user will connect to your application, and then it will be redirected to a login page that lets the user input his login and password on his Autodesk account. The Autodesk server will call back your application using the callback URL that you specified when you created the app on our developer portal. And this callback URL will contain a code that your application will then use to perform another request to the Autodesk server in order to request the final token. So in that authentication system, the user needs to have an Autodesk account on H360, and your application will use the requested token in order to access or manipulate the file of the users which are stored on the Autodesk cloud. So a change that we introduced in 2017 are the OAuth scope. The scope defines the data, which data is accessible for the token, and this concerns two-legged and three-legged application. On the three-legged, the scope defines the permission that the end user will need to approve on the consent page. So typically, you can see there on the right a screenshot of how will look the web page that is displayed to the user, and you can see here the permissions which are requested by your app to access the data of the user. So the basic permission is accessing the data for read, but then obviously you can also request write access, bucket creation, and so on. So the user will have to allow your application to grant permission to your application in order to access the files and manipulate the data. As of now, all the scopes are required for the application two-legged and three-legged. Also, an important security consideration is to provide only viewing read access to the viewing application. So basically, the client application which is using the viewer need to have a read access to the data. So your server application needs to provide a specific token which has a reduced scope in order to have a secured workflow. On the back end, on the other side, your application will request an extended scope. So typically, if you need to access the data for read and for write, then the token that you request on the server side has to be kept on the server side and not sent to the client. When you go to the documentation and when you open a specific endpoint for one of the Forge API, you can see the required scope for each endpoint. So for example, here this is the post job, and you can see that this endpoint requires a data read and data write or data create in order to be valid. The scopes are pretty straightforward. You can see here a list of the existing scope. So we've got data read, so when the application needs to access the data for read. So that's typically the case when you want to load some design in the viewer. Then you've got data write, data create, data search, when you need to place some data on the Autodesk cloud or on the storage service. And here we have the bucket create in order to create buckets on the OSS, bucket read, bucket update, bucket delete, and so on. One scope that is specific here is the code hole, and this scope is used for the design automation or the previously named AutoCAD I/O API. These scopes allow your application to execute code on the Autodesk server. All right, so let's jump to the data management API. So here is a diagram that illustrates the various services which are part of this API. So these APIs, you can see there, it's decomposed in several services. So we've got the project service that contains the hub, and under each hub we have a set of projects. Then we've got the data service. So inside each project, we have one or several folders. Basically, we have a root folder, which is linked to the project, and inside this root folder, we can have items or subfolders. An item represents a file that you upload to the service, and this API also manages versioning. So basically, the first time you upload a file, then you will get an item, and then you will get a first version of that item. If you upload the same file but a modified version of the same file, then the API under the service will automatically create a new version of this item. And then we have the OSS, which is the low-level storage, object storage service, which is powering the data management API. So we can see here, if I show you that here, we can see the three-legged part of the API. So we can see here, illustrated by this diagram, that the data management API and the A360 service is using the OSS in the background, and it's using a single bucket for all the file of all the users. So it means that you can, in order to access those A360 buckets, you need to have a three-legged token. You can also use the two-legged API and leverage the OSS in order to create private buckets in which you can upload your object or your files. But this API does not handle versioning. So in that case, you will need to, if you want a versioning system, then you will have to manage it by custom logic. All right, the other new features that have been added is the BIM 360 Docs API. So basically, you need to enable this API for your app, and the API just works with the data management API. It means that the hubs will just be listed as the other A360 hubs when you request the hubs collection through the data management API. So there is no specific API for BIM 360 docs. It's just an extension of the data management API. And also we added an attachment feature, so it allows you to link two versions of an items. So it's a link between two versions of different items. So let me show you this in a demo. So this is our developer portal that you can access at developer.autodesk.com. You can see here the list of API, so I can quickly show you the authentication here, and we've got the step-by-step tutorial. So get a 2-leg token, get a 3-leg token. So I'm just going to show you quickly the 2-leg token. So here is the scope I was just talking about. So basically, it's pretty straightforward. The scope is just an extra parameter that you had inside the headers of the post request when you request a token. So we can see here that we are requesting a data read scope. And in the scenario where you want to request more scope, you just have to pass a list of scope here, which are separated by a space character. It's pretty straightforward. All right. So here is the demo I created. I called that dm.autodesk.io for data management. And this is a pretty extensive example which is making use of the data management API and the other API. So basically, when the first time you will use the web page, it will ask you to log in because this is using the 3-legged. So let me just show you in another browser. Here I will run because I'm already signed in for the demo. So basically here when I press the user data, then this is the authorization page that you have to display to your user. So in that case, you can see here the user has to put his login and password in order to be able to authorize the app to access the file. So here I already signed in. I already signed once, but if you do it for the first time, then you will see after this login, you will see an authorization page where the user has to accept the various permission that your app requests. So let's get back to the demo itself. So you can see here the list. You can see there the collection of the various hubs that are retrieved from the API. So here is my personal hub, here is a team hub, and here is a BIM 360 hub. So under each hub, we have access to the projects. So you can see here that's the root project, and here are two different projects under that hub. If I go to A360, we can find the same thing here from the Autodesk A360 website. I've got my two projects here, and I'm going to show you some files inside this Forge project, which we can retrieve there. So you can see here when I expand this this project, we can see the list of items that it contains, and also the folders, and under each folder you can find some other items or some subfolders. The first thing I wanted to show you with this sample, so this sample is more like a test harness for developers. What I did is that I added some options here where you can right-click the various elements in the tree view, and you have some extra option based on which element is selected. So in that case, I selected the root project. So here, if I do the show details, we can see here some other options. So project details, root folder details, or root folder content. So if I click here, what I can see here is just the JSON payload, which is returned by the API, and that my application is just opening a new tab in order to show you this this response. So what you see here is actually the raw response from the API. That's what your application has to deal with when you send a request to the data management API. So we can see here I was requesting the information about a specific hub. I'm passing the hub ID and the project ID. So here I can see the content of my project. I can get the attributes. So this is the name of my project, and that's the root folder, and so on. So basically, based on this information, this JSON payload returned by the API, then I can build my user interface around that, and that's pretty much what is doing my app. And I'm just building some UI around the response from the API. So now, if I show you the root folder detail or the root folder content, for example, this will give us a bigger payload that contains all the items and the subfolders which are contained inside this this project. So we can see here this the folder. So I've got 2 folders. I've got a bunch of items as well, and those are the things that we retrieve here: folders, items, and so on. So basically, that shows you how you can iterate through the various data which are returned by the API, accessing the list of the hubs, accessing the project under each hub, accessing the items under each project, and so on. The other thing I can show you from there at the moment is are the versions. So let's pick up one of the uploaded files here, let's say the engine. So if I click here on this little icon, I will be able to explore the various versions. So we can see here I've got 2 versions for this specific item, and again the versions here are accessed from the specific endpoint based on the item ID. So here, if I right-click here, the show item version details. Here is the payload which is returned by the API. So that's the payload that contains information about all the version attached to this item. So we can see here is the first version, and here is the second version, version 1 and version 2 of the item. And obviously here I'm able to load one version or the other, but I will show you that when I talk about the derivative. Here is another tab here where I'm seeing the details about the item itself. I can open that in a new tab as well. So again, yeah, this is the response of the API that is specific to this item. And you can see here various data which is not shown in the user interface, like the display name of the item, the creation date, the date of the last modification, and so on. So you can see here all the metadata which is attached to this specific item. And yeah, other things which you can do from the samples is uploading files and downloading files. So here I can upload, with this icon, I can upload a new model. So let me navigate. Here I've got a very simple model, very small file, a DWF file. So I will upload that to the selected project or selected subfolder. And you can see here the files. The file is being added to the tree, and yeah, we can check here the version and so on, similar to the previous thing. So this is the first time I upload this file here. So here I've got a single version. Let's try to upload the file another time. So the file with the same name, inside the same project or the same folder, then the API should automatically create a new version for the item. So now you can see I've got version 1 and version 2 for this same item. Also, you can click those icons in order to download the data which is attached to the specific version. So let's download this version, you can see here, or download the data, the file which is attached to that specific version. All right, so that's pretty much it for the data management. I wanted to show you this is my BIM 360 hub. So from there I can access files which are lying on my BIM 360 account, and it's working the same thing, so it's exactly the same logic than the rest of the API. You don't have to do anything special in order to access those files, except that you have to enable your application to use the BIM 360 API. All right, so let's keep going. So that was it for the data management API. Let's switch now to the model derivative API. So the model derivative API is a web service that allows you to go from design data and is doing several things. It lets you translate the file, so that's the word that we use to extract the data to another format. Also, you can extract thumbnails from your design, you can extract geometry, and you can extract data, metadata, and properties of your CAD file. So concerning the translation, the model derivative API supports C++ format at the moment, and this number is growing. So there is a specific endpoint that tells you exactly which formats are currently supported. The OBJ export is available for all formats supported at the file level and also at the component level. So you can specify a specific component inside your design that you want to export to OBJ. You don't have to export the whole design. And some other formats like STEP, IGES, and STL are only supported at the file level. So here is the workflow concerning the model derivative API. You need to have a file available on OSS or on A360 or on the BIM 360. So the first step is to upload the file to the Autodesk Cloud. The second step is to post a job in order to request the translation to the API. So basically, if we want to generate a file that we can load in the viewer, we will post a SVF job. If we want to extract the file and convert it to OBJ, we'll post OBJ job, and so on. Once you post a job, the API will create what we call a manifest. So the manifest is a JSON payload that contains a description of what formats are available on the model derivative, what derivatives are available for this specific file. So at the moment, we can see here, we don't have yet a webhook or a push notification mechanism, but this is definitely coming in the near future. So at the moment, once you posted a job, the way in order to know that the translation is complete is to access the manifest and check the content of the manifest, check if the specific derivative that you requested is available or not. I keep losing my mouse. So if this specific derivative is not available, then you might just pause your application for a while, or just like set a timeout typically, and do that until the specific derivative that you're looking for is available. Once the derivative is available, then you can access the metadata endpoint that gives you access to the model hierarchy and the properties, and you can also download the derivative, so access the data, access the file like the OBJ and so on. Or in case of the SVF, you can load the model, the design inside the viewer. So here is a bit more details about posting a job to the model derivative. So concerning the composite model, so for example, you have an inventor assemblies composed of a main assembly, you might have as well sub-assemblies and part file. You can just zip all the necessary file inside a zip file, upload the zip file as a single file, and you have to set this compressed URN properties and also indicate to the service what is the root file. So what is the file that you have to open? Like if you are going to open the assembly in Inventor, then this is the topmost file that you need to specify. And on the Autodesk Cloud, the references will be resolved automatically. If you have just a single file like an IPT or a DWG or a DWF file, you can just upload the file by itself. One important precaution is that you need to keep the extension, you need to keep the same extension when you upload the file. So this is to let the service know which file it's dealing with. So typically, if you have your own file management system, you may rename the file to have your to handle your custom versioning mechanism, for example. So you can rename the name of the file, but if you do so, keep in mind that you have to maintain the correct extension of the file. All right, this is how the derivative API is working hand in hand with the data management API. So this is the diagram I showed you previously, and here is the derivative service that contains manifest, translation, properties, and hierarchies. And the derivative service will access either the version here of a specific item, or it can access directly the objects or files which are stored on OSS. So this is for the case of three-legged, and in the case of two-legged, where you have a private storage, then the derivative service will access the files here which you stored inside your buckets. So this slide here is there to mention that in the past, the only way to pass data to the derivative service was to use the object on the private buckets. Now we have an enhancement that lets you access directly the version. So every time the user will upload a design file to A360, then there is a service worker on A360 that will automatically translate this design file and generate viewables. So if you simply want to load the user file in the viewer, then you don't have to access the data which is stored here in the OSS. You can directly access the version and load that inside the viewer. Now, if you want to do some other operation like exporting the file to OBJ or to another format, then you still need to access the data here which is stored on the OSS. All right, we also had a couple of new formats that you can export to. So for example, you can export from Revit to IFC and DWG. So in that case, it's not a conversion of the Revit model to DWG, but if you are dealing with a Revit project that contains embedded 2D views, which are DWGs, then the model derivative lets you extract the DWG from this Revit project. The IFC conversion, however, is converting the 3D Revit model into IFC. We can convert as well Fusion to FBX. We can convert Step to OBJ, and we now also support max file inside the viewer. So you can upload your max file and create viewable for those. We also came with a set of packages that will make your life much easier as a developer. So we have the NPM official, the Forge official package for NPM. So you can install that to your app with npm install Forge API Node.js client. So this is for Node.js developers. You can find the GitHub repository for this package here. And we also have, since a few weeks, a .NET SDK that you can install in Visual Studio with the NuGet package manager. Install package the Autodesk.Forge. So yeah, let me get back to the demo on the derivative. So still using the same demo, I will now show you what you can achieve with the derivative service. So we can see here that we've got a little cube here. So this is the file I just uploaded previously. And basically, you can see that it's saying there is no derivative on this item, because what I did previously was simply uploading the file to A360 through the API. So in that case, my application is not using the derivative which have been generated, but is checking the data on the bucket. So I need to right-click here and generate the viewable. So here, what it's doing, it will post a SVF job. You can see here the format. So it will request to the model derivative API to translate that file and generate viewables. Now it's finished, so we can see here there is the little thumbnail attached to the document. And if I double click here, I will load that model inside the viewer. Here and so the other thing here I can play with are the various derivatives. So if I click here now on the black cube, then we can see that this other tab is loading the model derivative. So the first thing that I can show you is the manifest. I'll show you that. I will display that in a new tab. So as I mentioned previously, the manifest is a JSON payload that describes which derivatives are available for a specific file, a specific design. So we can see here, you can use that to check if the progress is pending or not. We can see here the region, and we can see here the list of derivatives which are available for this design. So here, since I requested the SVF, then there is a bunch of derivatives coming with the SVF. So there is obviously the graphics. There is also the properties. So this is, if I go back here inside the viewer, as you may know, the API also provides access to metadata. So those are the properties which are attached to the original CAD file. And this is what we see here. Those properties are coming from this database file. Then we can see we have several views. Or in that case, was just one view. The 3D view, in case of a Revit project, typically we may have several 3D and 2D views. We also have the thumbnail here that we can find, and that's pretty much it for basic SVF, 3D SVF. Then it gives us access to the hierarchy. So the hierarchy is, I need to refresh that. So the hierarchy is basically what we see here in the model browser. So that's the tree view that represents the various components under the model. Right, so here is the hierarchy. So all the data that I'm showing you here can be accessed directly server side. So it means that you don't have to load this specific model inside the viewer in order to access all this data. You can simply perform all those steps on the server side or from a service running on your backend. It's just because it makes more sense to show that visually through the web page. But yeah, this is pure REST code that you can perform with no UI at all, and you can automate your process based on that. So this is the hierarchy that we find in the model. Here, if I double click on a specific element, yeah, it displays that dialog that contains the properties for the specific elements. And again, yeah, all those properties are available from the API, so just pure server-side application. That's for the hierarchy. That's the, yeah, we can show that in new tab or properties. And also we've got the export tab. So here the export tab shows the available export based on the file format. So here it's a WF file. We've got an OBJ as
Philippe, we can't hear you anymore.
No.
Yeah, better. Thank you.
Yeah. Okay. So yeah, just let me know if the sound does that. So yeah, that's a DWF file. So in that case, I can export that to OBJ. So here, if I request the OBJ, let's request the OBJ translation. So it will
again, Philippe, sorry to interrupt you.
Yeah.
We can't hear you at all. If you
I'm not sure. Okay, I'm not sure what's going on. It might be the network.
It's better.
Okay. So I'm requesting an OBJ export for this specific design. So this might take a little while. And also here the SVF. So this one is just a feature that I added to my sample. It will just download the set of files which are used by the viewer, but this is not really an API which is exposed by Forge. You know, you can get the source code for that if you want to do some offline viewing, for example. But yeah, keep in mind this is not like an official API and an official endpoint exposed by the service. So I'm not sure. Get some jobs running. Let's wait for a while. Maybe I can switch. I've got this other model here. If I switch to this model, I think I've got in that case, yeah, I've got the SVF for this one. So here, if I ask the SVF, I did that before, so it's ready. So we can see here. I'll show you in my download. This is the zip that is returned by my application, and here you can see the list of the files. So these are actually all the files which are used by the viewer and which are supposed to stay on the Autodesk server. So if you want to do some offline viewing, then you can use that. You can download those files and you can load those SVF locally. So Cyril got a pretty good sample in order to do that you can check. It's called extract.autodesk.io. So if you want to do offline viewing, then go there and you can find some more information about how to achieve that. But that was not the main topic. And that's pretty much it for derivative. Yeah, maybe I can show you the Revit file here, so it's more interesting in terms of exports. So we can see it's a big file, so it takes a while to load the hierarchy. We can see here the available export for this file. We've got DWG. So this file is a Revit project that contains 2D views. So we've got here the DWG. You can download the various DWG attached to the project.
Philippe, you disappeared. We can't hear you at all.
Yeah. Can you hear me better?
No.
No. How, not sure how I can.
I think there's someone on the line, but which cut your line, maybe? I don't know. We can't hear you at all.
Yeah, I have no idea. All right. Is it going coming back or what? Yeah, can you hear me? Philippe? Can you hear me? Is it just two maybe or I think that's the question. Can you guys type the question if you can hear me clearly, or is it coming just from Philippe's side, or if somebody can just type
you're
the question?
back. You are back.
Just let me know.
On you off now. For a few minutes, maybe we can switch presenter and I can go through the package and security thing and we come back to you later.
Yeah, all right.
Yeah.
So let me.
Okay, let's do that.
Oops. Yeah. So here you can find the links to live demos I was just showing. That's the PM sample. We've got some of the sample as well there, and yeah, all samples come from with the full source code that you can find on those links. So I'll switch the presentation to Cyril. Hopefully the sound is better. All right, Cyril.
Can you see my screen, Philippe?
Okay.
Yeah?
No, right. Yeah. All right, says yes.
Make presenter. Right.
Go ahead.
You should see my screen. Philippe?
Yeah.
You see the screen?
Let me... Not sure. No, but just go ahead. It seems that the attendees can see your screen.
Okay. So if you go on GitHub, this is where we post the source code of our different package. So right now we have 3 official package. So we have the Node.js one, which is published here on the Java. And last week we did publish the .NET one. So if you're interested by looking at the wrapper source code, then you can just go there. And it comes with few samples. So it shows in VB on CSharp how you can use the API. So here the three-legged is just to show you how to do the three-legged, because usually it's a bit more complicated than two-legged. On the two-legged example are the simple sample. So if I go to the C#, because I just assume most of you know C#, the application itself is very simple. What it does is it does a two-legged authentication. It creates a bucket. It uploads a file, asks for translation to SVF, wait for the job to complete, and then it will start the your local browser to see the file. On every of these single steps, sample is present in the 3 package, Java, Node.js, on .NET, so you can see the differences between the different package. If you interested by the Node.js one, all you need to do is to go to npm.js.org and you search for Forge API, and then you have instructions on how to install it into your application. For the .NET one, that's the same thing. You go to Nugget, and the only thing you really need to do into your C# VB or whatsoever .NET application is to install that package into your solution. For Java, it's a bit different. If you go to the central Maven repo, we haven't yet posted the jar files. So what you need to do is on our GitHub repo, you have the Java SDK source code, and we tell you that we have the jars posted. So you would copy them locally, and then you can start using them. What I'm going to show now is a quick example I wrote using WPF on C#. And I want to concentrate on two things here. So the first thing is the package has been used into the application. So this is where you see the package being installed. And it has two dependencies. So REST sharp on the Newton JSON. So REST sharp for doing the HTTP request, on Newton soft JSON for parsing and serializing JSON response. We will be supporting the .NET Core version in a few weeks, so you could use it on different platforms. But right now, it's more like supporting the latest and famous .NET Framework 4.5 plus version. But we do have on the roadmap to support different version of the framework. This example also integrates a couple of things about security. One thing Philippe said at the beginning, which is very important, and we keep repeating to people, is that the forged keys should never go outside your company. And actually, very few people in your company should know these keys. It's like your protection system. So you have really to keep them secret. And what happens if you write an application in C#? Someone can read your code by disassembling the code, or just by using an hexadecimal viewer on your code, and it could see the strings and copy them. So you would need to encrypt them, and because obfuscation is not enough. So the way I did it into that application is in different things. So let me go through here. As you can see on my screen, hopefully, there is a password on a salt string which has been put into bytes, encrypted using a triple DES algorithm. And that triple DES algorithm will be used to decrypt, encrypt information to protect my keys. So if you don't do that, someone can just decrypt, disassemble, or use reflection on your C# VB assemblies and steal your forged keys. So you need to do something like that to protect that. Another thing I'm doing here is, in production, I have a thread which will be monitor the application if it's being debugged or not. If you debug it, including remote debugging, I will stop the application sooner or later, so the hacker will not have enough time to figure out what are the keys, and etc. So this sample will show you the basic minimum of protecting your keys if you write a desktop application. The application is right there. So when you log in, then you can choose whether which region you want to work with, US or EMEA. You can choose a bucket on your account which you want to see. You can drag and drop files. So let's say I'm going to take something not too big, like this one. and I drag it to the application. It's being loaded into my account, so now it's right there. So I can get the properties, and I can ask for translation. So everything the application is doing is exactly what Philippe explained a few minutes ago. And after translation, if I want to, I can see the file. So here I'm going to show another one because I know it's already translated. And I'm going to start the browser. And it connects. So it's a cube here, so nothing very interesting, but it was to wait. Okay, so now this one is translated. So just to show you, I was not faking. I can start this one, and then I have my object being translated. So you can do well, I can also show it into an embedded window if I want. So you can embed the viewer directly into your application. So it's a WPF window here. Again, it's all secured this time, so nobody can really steal the keys unless they're very clever. But that's how you could do it. So a bit more on the code. It's WPF. And for example, if I go here, so this is a login mechanism. So I have a function here, which is the OAuth exec asynchronous, because everything is asynchronous in a way that the UI is never blocked. So because if you were using synchronous code, then the UI would freeze while you wait for the answer. And when you use REST API, you never know if you'll get an answer. So you should always use asynchronous code. So this one is just using it's just using the API to do the call to the different API from the Forge. So this is where we do execute the call and you get a response. So that's different things you can do. So that's really what I wanted to show you and reinforce what Philippe said about being careful about protecting your keys, as well as using the correct scopes. So you limit the risk of exposing the information when you use a viewer, for example. So that's it. Sophie, do you want to take it back?
Yep. So I hope the connection is gonna be better.
Yeah, at least we can hear you well this time.
Yeah, I'm not sure what's going on. So show my screen. Let me know if you can see my screen.
It's good. Go ahead.
All right. So I hope the sound is going to be better. So yeah, the second sample I wanted to show you, still on the data management and model derivative, is this one, the OSS, Autodesk.io. So this one is, you can see, it's pretty much the same UI than the previous one, except that is using the two-legged storage system API on the background. So in that case, we are not accessing the file of the user on the Autodesk cloud. We are not requesting the Autodesk credential, at least for the user. And it's basically the application is implemented on top of the OSS. So it means that the file that you can see here are visible to everybody which logs into the app. So if you upload a file here, everybody will see it. So obviously you can use this API and you can add your own custom authentication on top of that if you don't want to rely on Autodesk 360. But in that case, you will have to handle on your side, I mean, with your custom logic, the user login and the authentication, and also the separation between the files for each user. But yeah, that's how it looks like. So the same thing, we can display files inside the viewer. So here I'm loading that one. We can upload files. We can create buckets. So here I can create a new bucket, whether the bucket is transient, temporary, or persistent. Let's create a new transient bucket. And you can switch region. If you go to storage here, I would switch to US. So in that case, you can see the bucket list get refreshed, and those are the buckets and the files which are I have created on the US region. And then the same thing, we've got access to derivative for each model and all right, so let's keep going with the demos, the presentation. So let's talk now about the viewer. So the viewer, it was called before the View and Data API. Maybe if you tried Forge a year ago. So we renamed that API, renamed that viewer because it's not actually an API. It's more the viewer is a component that's a JavaScript library, which is enabled and which is powered by the model derivative. So you upload your file using the the data management API, then you will translate the file to SVF using the model derivative. And then you can create a web application, which is using the viewer component in order to load the files on the web page. All right. So a few words about the viewing application. So if you go, let me go back to the developer portal. And so if I go here and let's go to the viewer here. So you can find a set of step-by-step tutorial to get started. So we've got here the basic viewer. So this is really the vanilla, using the vanilla API, the basic API that you can use in order to display a model inside the viewer. Then the viewing application that you can find here, the second step-by-step tutorial, and this is what is discussed here, is a wrapper around the viewer. So just don't get confused. That's an extra layer of API which is still using the same viewer on the background, but is wrapping a little bit the API in order to make it like more straightforward for the developers to load models, and also has some advantage when it comes to loading some specific extension that rely on data available with the items. So this is at the moment the recommended way from the development team. And this is how it works. So it's pretty straightforward. You're using the URN of a document. So this is the URN that you get from the model derivative. So it's composed by the bucket name and the object name that you use to upload the specific files. And once the SVF translation has been complete, then you can use that the base64 URN to pass it to the viewer. So the first thing that you need to do is to initialize the framework. And when the framework has been initialized, then you will create a new viewing application, you register a 3D viewer, and you load the document. So that's a pretty high level thing. So you can find more details if you check the basic application here. And also here I created a gist where you can find in more detail how exactly you initialize that document. So basically you're passing the URN of the the access, the URL, sorry, to access your access token. And then you can see it registering the viewer, and here you get the callback. So when the documents get loaded, so here the document is not is not the model itself. That's the higher level object that contains all the information about a specific design. So inside a single document, especially when we deal with Revit project, we can have several viewables. So in that case, you can see here that we are using the from the viewing application. So bubble search, we are getting all the viewables. So we are searching all the items which have a geometry type. So this will return the list of all viewables which are available under that document. And then in that case, we will select the first item in order to load the viewable inside the viewer. So this is really the function call that loads the data which is viewable and that loads the geometry and the metadata inside the viewer. And then we've got some callbacks if the document fails to load and once the item is loaded. All right, so viewing application, and yeah, so this is where the viewing application comes interesting, is when we are using documents which have several viewable items, and the reason is that the viewing application will store some information about all the viewable items under this document. So here, when we use this new search in-viewer search extension, which is provided as part of the API, you need to configure how you want to load this extension. So for example, here we want to enable the model tab, and so we want to enable the model tab, the related items tab, so basically you have to provide the session ID here, can just be a generated UID, and you pass the configuration of those extensions to the viewing application, and then the viewing application is doing the rest. So let me show you here a live example of using this viewing application. So yeah, the thing that you get here with the viewing application is the list of all the viewables which are available for this specific document. So we can see here I've got 3D views, and I also get a bunch of 2D DWG views which are part of the same project. So if I click one of those, then it will automatically load this different viewable. And the extension I want to show you is this one. So once you enable the search, the in-viewer search, then this is what you get. And you can see here the recent searches that I did. So if I look for window or glasses, then you can see here the list of all the elements which are matching that search. So in that case, the list of all the window. So you can see here I've got two tabs. So that's the view tab, this view tab. So these are all the elements which are available inside that view. And these items here, it's also performing a search not only across this 3D view, but across all the other 2D views. And potentially here, if I have multiple 3D views, then it will search also the other 3D views. And so this is made very easy if you use the viewing application. Yeah, if you use the vanilla viewer, then you will need to pass much more information and to fill up some fields in order to for the search extension to look through all the available items. So here, let's say if I click a specific item here, it will automatically load the specific views that contain that the element which I clicked on. I'm not sure why this one doesn't let me. Oops. Let me maybe try another. All right. Let's do it again. Not sure why this specific item cannot be found. All right, and in the search. Come on. All right, I might. So let's try to find some, hopefully inside this item, maybe that one, and here. Yep. All right. You can. This one is not. That's actually not a DWG, but you get the idea. All right. So let's keep going. So that's the Enduro Search extension. You can find this sample. The another extension that has been added to the API is the zoom window. So this allows you to perform, to draw a 2D window on the model and zoom on the region. So if you use AutoCAD, then you must be familiar with the workflow. Let me show you here a quick demo. So the extension needs to be loaded programmatically. It's not loaded by default. So if you just open a model inside the viewer and you don't customize the viewer through the API, this is not available. You need to explicitly request this to load this extension. So here is a small sample that I created where I can type some code and dynamically load the code in the viewer through an extension. So if I load that, then you can see here that there is a new icon that appears, and that's the zoom window feature. So I can draw a 2D window and zoom on it. There we get the idea. All right. The next thing is the hyperlink. So here I don't have a live demo for that, but basically the idea is that you will be able to create links that takes you from one drawing or from one view to another. So you can see here a set of animated GIFs that shows the how it works. So basically, when you click on a hyperlink, it will show you a preview of that linked drawing, and the user can click on the drawing. It will load that drawing to the viewer, and then you can click the view button, and then you can click the back button to go back to the views that you used previously. All right, another feature are the markups, so the 2D markups that have been enhanced. We added two new markup types, the polyline and the polycloud. You can see those again in animated GIFs. Another feature that has been added to the API is the geometry snapping. So when you create the markup, you can see here that automatically the API will snap to the 2D lines in order to let the user create the markup which are aligned with the existing geometry on the 2D drawing. There is a new API for the view cube, so you can change the camera orientation through the code the same way that the user would click on a specific face or an edge or a corner of the view cube. So this is how it works. You can specify top right or back bottom left and so on. And also the view cube can be used with the viewer 3D instance, what we call the headless viewer. So this is the viewer coming without any commands, without the default Autodesk commands like the default controls that you can see, for example, here in the toolbar. So if you want your application to look very, very custom, you can just use the headless viewer. So it means that you don't get all the features here implemented by Autodesk, but you still can use the view cube, which is pretty handy for navigation. A log error API. So now you can specify through this logger set level. You can specify the level of error which are being output to the developer console. So we can set it to debug, log, info, warning, error, or unknown typically for production builds. The node coloring API, so this can be used for 2D and 3D drawings. So basically you're passing an array of DB IDs, of component IDs, and a vector that represent RGB values of the color. And then this will color those specific components. This will put an override on the color, and you can clear the colors with the clear theming color. Let me show you here in the demo. So here, it's pretty straightforward. I'm adding an event listener for the selection change. And inside the handler, I will get the DB ID of the selected component, and I will set the theming color to some different color and remove the selection. So this is the behavior, the normal behavior with when I select an entity. And if I load the extension, then you can see here the theming color that is applied to the selected element. So if I unload this extension, then it will clear the theming color. So I can see here it's no longer there. And so concerning rendering settings, so when they are available, the rendering settings from the model will override the defaults and the user predefined preferences. So typically if you translate a model from Fusion, for example, and you set some settings, some rendering settings in that model, then this will be saved with the translated model, and it will be loaded automatically inside the viewer. Things like the light preferences or the background image can be defined. If you want to bypass the settings, then you can use this tag ignore producer. So in that case, the default settings which are set by the user will be used. This concerns the dialogues that you get in the viewer. So we can see the rendering settings here, which are coming with the model. So have a different color. So in that case, the ground shadow, reflection, and the environment map are coming along as settings embedded inside the model. There's been some work as well done on the VR extension. So now we support WebVR1, and also there is some logic that we call the consolidated mesh support, which makes the viewer more performant, especially for VR devices. So this allows the model to be drawn with fewer draw calls and provide some better performances to display large models. We support iOS and position tracking on VR systems such as HTC Vive or Oculus. And a breaking change for the get screenshot API. So in the past, you can see here the old way, you could just call the viewer get screenshot without passing any parameter. This was returning the blob URL of the screenshot. Since the version 2.9, then you need to provide the 3 parameters, which are the width, the height, and the callback function, which now receive the blob URL. So it's a pretty straightforward migration if you are using the get screenshot API. And some other remaining things. So there is a method on the viewer.model get document node. This returns an object that wraps the definition of the manifest, which is for the loaded model. So you can access some information about the model from there using this method. On the 2D drawings, you can swap the background color from white to black, so you can invert the colors for visibility. And also memory management enhancement for mobile. And the walk-through feature has no gravity, so you can do things like walking up and down the stairs when you are using this first-person walk-through mode. All right, that's pretty much it for this presentation. So you can, if you haven't done already, you can register and get a key on our developer portal. So that's developer.autodesk.com. Basically, you need to create a new application. You select the APIs that your application has to use. And then you will get those the client ID and client secret that you can use to request the Forge tokens. Documentation and tutorials, so you can find some basic step-by-step tutorial here. And also we've got an extensive set of samples on our GitHub repository. So that's the github.com Autodesk Forge. So let me show you here. That's the repository. And we also have here a custom page where you can filter the various samples. So you can filter here by API. So let's say you are just interested inside in the model derivative or the viewer. You can filter by languages, so JavaScript, CSharp, and so on, and by popularity. So those samples are, this page is actually showing links to the samples, to the same samples that we have on our GitHub page, but it just lets you filter if you have some preferences, programming language preferences or APIs. And finally, if you want to ask question, our main media for answering developer question now is Stack Overflow. So if your question is not confidential, then please feel free to use Stack Overflow. You can use some specific tags here, like Autodesk Data Management, Autodesk Model Derivative, Viewer, Autodesk Forge. So let's say I want to ask a question that concerns the viewer, then I will use Autodesk Forge and Autodesk Viewer tags. And when you do so, we'll get a notification that let us know that a question has been posed using those tags, and we will answer your question. Now, if you want to provide some sensitive files, or if you want to use if you want to ask some question privately, then you can still use our private case system to ask us private questions. All right, so that's pretty much it. Maybe Cyril, do you have to add something? We can start answering questions now. So
the only thing I really want to tell is that we do have 2 accelerators coming in Europe. One will be in March in Gothenburg, and the other one will be in June, I think, in Barcelona. So June will be the week of the 12th of June, Barcelona, and the accelerator in Gothenburg will be the week of the 27th of March. So if you're interested to join us to work on the viewer, on the model derivative API, or any other API, you're welcome to join us to work with us. So it's a week where you sit with engineers and you work as you would in your office, but you have direct access to Autodesk engineer to help you on doing your application. So if you're interested, just drop us an email. I think there is a registration form on the forge.autodesk.com website. So this is where you can probably register. But if you have problem to find it, just email me. And yeah, we can open the floor for questions. So if you have any questions, please ask.
Cyril, I can see that there's been some problem with broadcasting my screen. Are you able to see my screen right now?
Yeah. It was resolved. It was resolved. I got an email from someone.
Okay, that was really annoying. So I can see just one question here. The cube in the upper left corner in H360, is this available in the API? I'm not sure, so let me check.
I already replied to that, Philippe.
Yeah,
So
okay.
yes, it is.
So,
You can show and hide it through API. And you can also call the basic functionality of the cube. So if you want to see front, top, etc., you can, as well as going home. So you can
yeah,
call the defaults
uh,
behind.
is the view cube the same? Is it the default view cube? Because some of the components are customized in H360. So I'm just loading a model here to make sure. Yeah, so if you're talking about this view cube, then that's the same. Yeah, this one, yeah, I'm not sure. All right. So yeah, this view cube is the same than in the plain viewer. All right. Any more questions, guys? Just feel free.
Well, there is one,
Yeah,
which
yeah.
is upload a file to a bucket on OSS. I must have the full path to it or just on the streaming? So I'm unclear on the question, so let me answer that. You're going to stream the binary data on OSS. Wherever your file is on your system doesn't matter. You load the binary information, you upload it through the put verb onto OSS, and you store it wherever you want on the bucket. You can have path information in the name you use on the bucket. So I hope I answer the question here. So I see Philippe answers the other one. If a 100 megabyte model on BIM360 is downloaded to a local location using the, what should be the cost implication on this? You mean on consuming Forge cloud credits? None. The data management API is entirely free, so upload downloads is free, and there should not be any impact on the cost. Any
Yeah.
more
So the
questions?
question was about the left side cube. Yeah, which is that's a custom component available only on H360. So I don't think there are plans to expose that to the API. But basically, what you get here is that's just a custom UI around the feature which are exposed by the API. So yeah, you could get the same thing, but yeah, you would have to implement it yourself. So which yeah might be a bit of work.
Thank you, Matt.
Thanks. Yeah, sorry for the network problems. So yeah, guys, just feel free if you have any more questions. We're just gonna stay online for a couple more minutes. All right. So no more questions. Okay, guys, thank you for watching, and yeah, feel free if you have yeah any questions, technical questions. Feel free to use Stack Overflow. Ask some
So
more questions.
there is a question on pricing, Philippe. So can you go on to the
Yeah.
developer.autodesk.com
So you get
pricing?
yeah, specific
I'll talk about
pricing
it. Um,
section here.
Yeah, so the pricing here works this way. So you can see that the data management API, there's no additional cost, whether you're on trial or subscription. So data management is really about upload, download files, how you manage files. So whether you're using OSS or BIM 360 or Autodesk 360, there's no additional cost using that API. The model derivative is the only one which is a bit complex because we have the notion of complex job and simple job. So consider that a simple job is like translating an AutoCAD or Inventor file, where the complex job could be a Revit file or Naviswork. And the difference is that usually a Naviswork or Revit file takes a lot of more time on let's say machine time to compute and translate your design file into SVF or other formats. And that's the reason why in the last 2 years we were monitoring how people were using the API and how much that was costing on our side. And this is how we came up with this pricing. And it may change in future, but right now this is what the pricing is about. So you can do the math. If you have a Revit file, small or big, it will cost you 1.5 cloud credits. And that is a complex job. If you have an AutoCAD file, you can already say it's 0.2 cloud credits. So whenever you kick off a translation, whether you go to SVF or you export to OBJ or so ever, that's a translation job. So that's where you kick off the counting. The viewer itself is just consuming the SVF or the bubble, so there's no additional cost. You can install it on your own private cloud, use it from our own cloud, install it or consume it as an embedded component into a desktop application or mobile application. No additional cost associated with that. So last question I usually got for EBA customers or people on TokenFlex is, can I translate TokenFlex or other Autodesk Cloud credits into Forge Cloud credits? The answer is today no. You really have to have your own Forge subscription to consume the API. On today, there's no other way to get it. So for people who wants to start developing on Forge, you can start with a trial, which will give you 500 cloud credits for 12 months, starting at the day you start the trial. And you can try the API, and after, if you're happy, you go through the subscription. I hope I answer your question, Matt. If not, please let me know.
We got another question about the CSharp API. Is it fully functional? So yeah, you can start using it. The package is available on NuGet. So obviously, yeah, they might have some issue that that we didn't spot. But so far, yeah, this is working. So it's been used by Cyril in his sample. So if you find any issue with the API, with the SDK, then feel free to log an issue from the GitHub repository, and we'll fix that as soon as possible.
Oh yeah, I think I forgot to say one thing. Maybe if someone asks where is my sample posted, I can give you the link. I think I haven't shown where it was.
The link was in the presentation. Let me get back to
with the WPF
yeah,
sample.
that's this one. Oops.
Oh yeah, yes, it was there. I just see it. Yeah, so it's right there. And there is two branches. So there is a master branch which is not secured. It just shows the let's say it's a way to see the sample working and just to show the functionality. If you want to see the secured version, you have to use the secure dev branch. But the README says that, so you should be fine. But yeah, thank you, Philippe. Yeah, that's the link. Any more questions from anyone? No? Okay, so let's call it a wrap. And thank you again, Philippe, for this, and thank you everyone for attending. I know that, so remember, this was recorded, so we are going to post this presentation on recording pretty shortly. I'm sure Stephen will let you know when and where it will be posted. Thank you, everyone, and see you another time. Bye-bye.
You guys, good luck.